Hello dear students. Now let's begin with our next unit of our course, and we are going to start with the volume 2. It is our second book of chemistry. The second book contains a total of 4 chapters. The chapters are haloalkanes and haloarenes, alcohols, phenols, ethers, aldehyde ketones and carboxylic acids, and amines. Other than that, biomolecules are also there, but these main 4 chapters comprise your organic chemistry. Along with that, biomolecules is also a part of organic chemistry. Now we are going to start with the first unit of this volume, that is haloalkanes and haloarenes, and in your examination you are going to have 2 units, that is solutions and haloalkanes and haloarenes for your first test. Now what type of questions are asked from the organic chemistry unit? From this organic chemistry, out of these 4 chapters, we'll be having conversion questions, we'll be having nomenclature questions, then we'll be having the mechanisms. In class 11th we were not having mechanisms, but in class 12th we are going to have some mechanisms also. We'll be having give reason type of questions, then we'll be having the identify the reagent type of questions, and then we'll be having complete the reaction type of questions also. These type of questions are asked in the board examinations. Now we have to start with this organic chemistry, and today we are going to start with haloalkanes and haloarenes. In the board examination we can expect 4 marks from this chapter, 4 marks, or maximum to maximum 6 to 7 marks. Now let's begin with this chapter. You already know that haloalkanes and haloarenes, what are these? You have studied these in class 11, but now we will be having a detailed look on these haloalkanes and haloarenes. What does the term halo means? Halo means halogen, and alkanes means the carbon chain on which this halo is attached. Similarly, halo here again means halogen, but these arenes means the benzene and the benzene compounds on which the halogen is attached. So when on a carbon chain, or when on the alkanes, when the halogen group is attached, they will be known as haloalkanes, but when on the benzene or the phenyl compounds we have halogen attached, then those will be known as haloarenes. These are also known as alkyl halides. These are also known as aryl halides. These are represented as Rx. R stands for the carbon chain, X stands for the halogen, and here AR. AR stands for aromatic compounds or benzene or aryl. Now when the hydrogen of alkanes are replaced by the halogen, means instead of H you are using X, the haloalkane is formed. So haloalkane is derived from alkanes only. In haloarenes, what will be happening? One of the hydrogen from the benzene will be replaced by halogen. That time from the benzene compound the arenes will be forming. These will be known as the haloarenes. Means from arenes we'll remove one hydrogen and we'll add halogen, then it will form haloarenes. Now in this chapter, the first thing that we are going to see is classification of haloalkanes and haloarenes. Now there are some methods on which we classify the haloalkanes and haloarenes. The first method is on the basis of number of halogen atoms. Means on the main compound how many halogen atoms are present means what number of halogen atoms are present. Those will classify these haloalkanes and haloarenes. Suppose we have only one halogen atom attached to this methyl group. This is R group. To this, if we are having only one halogen atom attached, then it will be monohaloalkane. Mono means single halogen to the alkane. This is known as methyl chloride or chloromethane, as we have studied in the nomenclature. Dihaloalkane consists of two halogen atoms attached mainly to R. Then trihaloalkane will contain three halogen atoms will be attached to R, and polyhaloalkanes where more than three halogen atoms are also attached. Similar is the case for arenes. We have monohaloarenes wherein the benzene only one halogen is there. Suppose in the benzene we have one chlorine, that is a chlorobenzene. Similarly, dihaloarenes are there. We have 1,3-dichlorobenzene. Similarly, trihaloarenes are there where the 3 are there, like 1,3,5-trichlorobenzene. So these are the classification which is based on the number of halogen atoms. The second is on the basis of hybridization of the carbon to which the halogen is attached. So we are going to see that the halogen is attached to a carbon because it has to form the haloalkane or haloarene, so it must be attached to carbon. Now what is the hybridization of that carbon? Where means whether the carbon is sp3 or the carbon is sp2. On the basis of that we again have the classification. If the carbon on which halogen is attached is sp3. In that condition, we'll be having three further cases, that is alkyl halide, allyl halide and benzyl halide. If the carbon on which halogen is attached is sp2, that time we'll be having two further types, that is vinyl halide and aryl halide. So first of all, we will see when the halogen is attached to sp3 hybridized carbon. In sp3 hybridized carbon, we know that the carbon will be attached to how many of more? It will be attached to, means how many bonds it will be forming? Carbon will be forming 4 bonds. In that condition, it will be sp3 hybridized. Means it should be attached to 4 other atoms. The other 3 can be anyone. One should be halogen. Okay. Now first condition is alkyl halide. In alkyl halide, where this Rx is there, the simplest case, here we have primary alkyl halide, secondary alkyl halide and the tertiary alkyl halide. Now what is the meaning of primary, secondary and tertiary? We do not mean this with a reference to halogen. We always mean this with the reference to carbon. Means in the primary alkyl halide, the halogen should be attached to primary carbon. Now what is the meaning of primary carbon? That sp3 carbon which is attached to only one carbon and the other atoms being hydrogen, like chloroethane. The secondary alkyl halide is that where the halogen is attached to secondary carbon. Now this is the 2-degree carbon. Students get confused. They think that halogen is secondary, but halogen can never ever be secondary. Carbon can be secondary. Means there is one hydrogen and two carbons. When the carbon is attached to two other carbons, then it is secondary, and when the carbon is attached to three other carbons, it is tertiary. The example is 2-bromopropane, and here when we solve this we get 2-chloro-2-methylpropane. Now how are this nomenclature coming? That we'll be discussing. That let us see that 2-bromopropane. We know that we select one chain, so we put the numbering, and then from numbering we select that where this bromine is attached, that is 2. So we'll put 2, then this dash, then bromopropane. And similarly here also numbering, it can be like this way. So in this way so by numbering you will get one carbon on the 2 only and again one halogen on 2. So we'll write here according to alphabetical wise, because this is methyl and this is chloro. C comes first then M. So 2-chloro-2-methylpropane. This is the first case of alkyl halide. The second is allyl halide. What is the meaning of allyl? Allyl means when you have sp3 carbon only, but this sp3 carbon is attached to sp2 carbon, means doubly bonded carbon. See, what was the condition? That halogen should be attached to sp3 carbon, right? So here also halogen is attached to sp3 carbon only, but this sp3 carbon is attached to sp2 carbon. This is our sp3, so our condition is satisfied here only, but it is attached to sp2 carbon. In that condition we talk about allyl halides. Now these are also of three types: primary allylic halides, secondary allylic halides and tertiary allylic halides. For example, when one more carbon is there, then it will be secondary, and when two carbons will be there, then it will be tertiary, and when there is only one carbon, it will be primary. So these are the allylic halides. The third is benzylic halide. In benzylic halide, what do we have? We have sp3 carbon which is attached to sp2 carbon of the benzene ring. This carbon, this carbon which we are seeing here, this carbon is sp2 carbon of this benzene ring. Now our sp3 carbon is attached to this sp2 carbon, similar as this case. But what is our condition? We require this halogen to be attached to sp3 carbon only. This is satisfied. Okay, because we require one sp3 carbon to which halogen should be attached, no matter that what this sp3 carbon is further attaching with. So this is our again the this sp3 carbon halogen bond. Now again here we can have primary, secondary and tertiary. When only this sp2 carbon is there along with this, means our sp3 carbon is attached to only one carbon, it is primary, like this way. When when our carbon which is sp3, so this is wrong actually, this is actually wrong. Here what should we have? We should be having this thing, that This is our carbon where our halogen is attached. This carbon is attached to one carbon here and one carbon here. So that will be our secondary, and our tertiary will be that when our this sp3 carbon is attached to one here and one here. This will be the tertiary. This will be the 3-degree benzylic halide. So these are the examples here. So don't get confused with these figures. These figures are wrong. Next we are having sp2 carbon halogen bond, where the halogen has to be attached to sp2 hybridized carbon. Means the condition is that we should have doubly bonded carbon atom. We have two cases, vinylic halide and arylic halide. In vinylic halide we have a halogen which is attached to sp2 carbon, and this sp2 carbon is doubly bonded. So because it is doubly bonded, it is sp2. Suppose we take this example, we have to we have to give the name to it. So according to nomenclature we'll put the numbering 1, 2 and 3. On 1 we are having bromo, so 1 bromo, and we are having 3, so prop, and on the 1 position only we are having double bond, so prop 2ene because it is alkene. There are aryl halide also. Aryl halide are those where we have the halogen directly attached to the sp2 carbon. Please don't get confused between benzylic and arylic. In benzylic we had that halogen which was attached to sp3 carbon, but this sp3 carbon was attached to the benzene. But in the case of arylic, we directly have the halogen attached to the benzene, means to the sp2 carbon of the benzene. Suppose this is the chlorobenzene, and here also you see that halogen is attached to this carbon only, so this is sp2, so that's why it is also arylic. So it is 1 chloro and here 3 ethyl benzene. So this is over here our second case. And also don't get confused between the arylic halides and the vinylic halides. In allylic halides we had the halogen attached to a carbon next to doubly bonded carbon, but in vinylic halides we have direct attachment of halogen to the sp2 carbon. Let us look at the brief nomenclature of this chapter so that we'll be sorted with this thing. Now see what is this given over here. The first is this one. Now if you number it, how do we number it? We know that we start from wherever our functional group is attached. Here is our functional group, so we'll name the chain, we'll number the chain from here. Now we have the 3, so 3 carbon denotes prop, and on 1 we have the bromo, so we'll write 1 bromo, and because no double bond is there we'll directly write propane. Second is this, again we have to start with the numbering like this only. We cannot start from here because we have to include this carbon also, because we have to select the longest chain. That rule also should be kept in mind. So here it will be 2 chloro propane. Third, here we have this kind of condition. Here you see this functional group is attached to the ending, so we start from the terminal functional group only, and this will be given more priority than the methyl group. So 1, 2 and 3. So what do we get? We get on 1 attached chloro, so 1 chloro, 2 methyl propane. Okay, next is this, simply we can write it as bromo benzene. Next is this, again number it, start from the functional group 1, 2 and 3. So we have 1, 3 dibromo, di why? Because 2 are there, dibromo benzene. Here 1, 2, 3, 4 and 5. So we'll be having 1, 3, 5 tribromo benzene. Here again select the longest chain 1, 2, 3 or 1, 2, 3 anything. So it will be 1 chloro and 2 methyl groups are there, so 2, 2 dimethyl propane. Here longest chain, so 2 bromo propane. Now see this condition, this condition where we have directly on one carbon we are having 2 halogen. This is the case of jam dihalide. So 1, 2, you will be having 1, 1 dichloro ethane. Please remember the condition of jam halide. In jam dihalide, you have the one carbon on which two halogens are attached together. That's why dihalide, but jam dihalide. Now there is another condition where we have two carbon atoms on which one halogen atom is attached. This is known as vicinal dihalide. Vicinal dihalide, and that one geminal dihalide. Again number it. It will be 1 2 dichloroethane. Now these kind of questions are also given in your NCERT examples. Now let us see how to solve them. These all are from the NCERT only. Now in that condition, these bands are all the carbon atoms. So this is one CH3, this is next carbon, this is next, and this is next. Okay, and here we have bromine to this carbon. Now this carbon also contains what, CH3 right here, and this carbon means first, after first, second and third, between second and third carbon we have a double bond here. Now we can solve it easily. How to solve it? We'll be directly numbering it. And now how to number it? So we'll start from here, because you have to select the longest chain as well as include the functional group. So we'll be having 2 bromo pent 3e. Now let us see the next one, this. Again to solve it, these are the hydrogen only, okay. This and this is carbon, double bonded. This is a carbon, and here is a bromine, and here is again a carbon, and here is also a methyl. Let us solve this again like this way, to include a longest chain and the functional group. Solving this, what do we get? So here we'll be getting 2 bromo. After that we'll be having but 3e. In this way we can easily understand the nomenclature. Now let us begin with the next part, or in the last part for today, that is the nature of carbon halogen bond. Now you should know that in the haloalkanes as well as haloarenes, we have one carbon halogen bond. Now this carbon halogen bond is very polar in nature. What is meaning of polar? Where one element is very electropositive and one element is electronegative. In the condition of carbon halogen, the carbon tends to donate its electron pair, and the halogen will try to attract those electron pairs which the carbon has. So in that condition, what will happen is that the halogen will become electronegative and the carbon will become electropositive. Because these electronegative and electropositive elements are bonded, the bond becomes polar. If suppose we have two same atoms, suppose we have only carbon and carbon, so in that condition no one will be electropositive and no one will be electronegative, so the bond will be also non-polar. Or we have two halogens together, suppose chlorine and chlorine, in that condition also both of them will be having the same polarity, that means the bond will be non-polar. But here we have one as the electropositive and one as the electronegative, that's why the bond is very polar, highly polar, because of the electronegativity difference between carbon and halogen. Now see carbon halogen bond length here. This bond length generally increases from top to bottom in the group. When we move from top to bottom in the group in the periodic table, we see that the carbon halogen bond length is increasing. Why? And for what respect we are talking about? With respect to halogen. Means we know that in top we have fluorine, then chlorine, then bromine, and then iodine. So when the carbon fluorine bond is seen, it is shorter. Carbon chlorine more longer, carbon bromine more longer, and carbon iodine longest bond. Why it's so? It is because the halogen atom size is increasing. We know this, we have already learned in class 11 that as we go down the group, the size of element will increase, and because the size of element is increasing, the electronegativity will decrease, because the nuclear charge will decrease, and because of this the bond, now because electrons are not shared that strongly, so the bond will lose and will become longer. In that condition we can easily say that the bond length will increase. So this is the nature of carbon halogen bond and the variation of the bond length with the changing halogen atoms.